Hello everyone, welcome to Rasayan Academy, and today we are going to talk about IR spectroscopy structure determination, and this is the third video in the same series. So guys, before moving on to our structure determination, let me introduce myself. My name is Jagriti Sharma and I am an educator on the Unacademy Plus platform. So guys, you can follow me over there if you want updates on regular classes. Right, so basically we are having a lot of special classes. So these special classes are the free 1 hour recorded sessions, okay, and basically you can attend the live class, right? If you follow me, you will get regular updates and you will be able to attend the live class with me. And in those live classes, basically before the exam, we have been doing a lot of previous year questions and practice questions. So I hope that if you come up and if you join the Unacademy, joining the Unacademy is for free. You can just register and come and see those free live classes. You can attend those live classes. You can also interact with me, right? So it's very interactive, and definitely you can come and see. And if you are not able to attend it live, you will be able to see the recorded session. So right guys, you can see a lot of recorded sessions with a lot of previous year questions, lot of practice questions, okay, for the chemical sciences definitely. And guys, the Plus platform is a paid platform. So basically what we are having is the special classes are just a glimpse of what are the type of classes on the Plus platform. So basically we are having 1 to 2 hour live session on the Plus platform, and they are basically aimed for the syllabus completion for the CSIR exam, for the definitely the syllabus completion, along with that practice session, along with that doubt solving session. So there are a lot of doubt solving sessions which are very helpful to the students, and we also do a lot of practice in the doubt solving class as well. Alright guys, so there are various subscription packages available: 1 month, 3 month, 6 month, 12 month and 24 month. So you can just see the content over the Unacademy, and definitely after that you can decide if you want to subscribe or not. And if you are right now, if you are thinking about preparation for the June 2020 exam, I would suggest you to take the 6-month pack, because in the month of December itself, from 18th of December, we are starting a new course on strategy of for clearing the June 2020 examination. It is not only strategy, we will also be discussing the exam pattern, paper pattern, about what are the important topics and what is our study plan for the next 6 months. How are we going to crack the exam in next 6 months? The study plan is also included in the strategy course. So definitely I would suggest you to subscribe right now, because this course is a very important one, and the things are not going to be repeated after we start studying from January. Alright, and if you are M.Sc student, you can think about taking the 1 year or 2 year subscription. Definitely depends on you guys. And this is my code Jagriti S. By using an educator's course, you are going to get a 10% discount. Okay, so never subscribe without using an educator's code. Okay, so this is my referral code Jagriti S, and if you like my content, then you can use it. Okay, thank you so much guys for hearing me out. Alright, so now we are going to start with the IR spectrum of alkynes. So we have talked about the IR spectrums of the hydrocarbons basically in the last video, and also we talked about the IR spectrum of the cis and trans alkene, lot of effects, conjugation effects, the ring strain, for the exocyclic and the endocyclic double bond. So a lot of things we talked about. Here we are going to start studying this IR spectrum of alkynes. Okay, so as we can see over here, we are having, I've taken a spectrum already. This is a real spectrum for this compound over here. So we are basically having so this is our heptine system. Basically there are 7 carbons over here. Just a second. This is 5, 6, 7 and 8. Basically this is our octane system, and this is terminal alkyne, right? So this is our terminal alkyne. So guys, we have 2 very major important peaks that we have to look for in the alkyne system. First thing is our carbon hydrogen stretching. So if it is a terminal alkyne like this, then only the carbon hydrogen stretching frequency is going to be available at a definitely greater than 3000, because here we have talked about previously that the sp carbon-hydrogen bond is going to have a greater stretching frequency as compared to sp2, and it is also going to be greater than sp3. Alright, so this is what we have discussed before. So definitely it is going to be near 3300 centimeter inverse. Alright, now the second thing is that we have to observe is the carbon-carbon triple bond stretching vibration, and it is going to be around 2100 to 2250 centimeter inverse. So guys, these are the only two values and you have to remember them because they are very handy, and there are only two major values for the alkyne system, isn't it? And it is also a medium peak over here that we see, and the carbon and hydrogen stretching is a very strong peak as we see over here. Okay, so the stretching frequency for both the CH as well as CC bonds we have to remember. Now moving on to the fingerprint region, moving on to the bending vibrations, as we can see that we also have a bending, characteristic bending vibration over here. So this is around, okay, so see, in the case of alkenes we saw CH2 CH3 bending basically, which was around in the case of hydrocarbons it was around 1300 to 1400, basically 1475 basically. Okay, and this included both the CH2 and CH3 bending. So here what we are having is here this bending vibration is around is greater than 1400. Alright, so this is for the CH2 and CH3 bending vibrations. Okay, so again the value is approximately similar, just that it has increased a little bit. Okay, it has moved towards 1500. Okay, so the CH2 and CH3 bending vibrations can be seen over here. Now after this we can see a characteristic peak for the carbon hydrogen bending. Alright, so the sp carbon and hydrogen bending, this peak we can see over here, and this is a sharp basically a broad peak but then a strong one at the 650 or let's say around 650 or 660 centimeter inverse. Okay, so this is what we see over here in the IR spectrum for alkynes. If it is a terminal alkyne, definitely we are going to see the carbon hydrogen stretching, carbon-carbon stretching, carbon CH2 CH3 bending, and carbon hydrogen bending as well. So these are our characteristic peaks. Now what are the factors that are going to affect the frequency? First of all, conjugation shifts the absorption to lower frequencies. Definitely it does, we have talked about it, because it decreases the force constant. Absorbance for symmetrically substituted alkynes may be weak or absent. So guys, in this second point we are not talking about terminal alkynes, we are talking about substituted alkynes like this. So if we are having symmetrically substituted alkyne like this, then what do we have? It's a very the molecule is symmetric and there is a very less dipole moment, so definitely the absorbance, which is basically the intensity, which is basically determined. So guys, these terms are very correlated. Okay, so I would just suggest you to remember this: absorbance, molar absorptivity coefficient, intensity, and dipole moment. Okay, so these are very interrelated terms and they can be asked in a MCQ question very easily. Okay, so absorbance for symmetrically substituted alkynes may be weak or absent because of very low dipole moment. Yes, we know that. Alright, so now we are going to move further and see some examples. Okay, so here we are talking about 4-octane system. So guys, why have I taken this 4-octane? First I had taken 1-octane. In the last example I had taken 1-octane terminal. Here I have taken 4-octane because over here, as I can see, it is a substituted alkyne system and there are how many groups? 2 CH2 and 1 CH3. Here also it's same, so basically it is symmetrically substituted alkyne system. Now let's check for the carbon-carbon triple bond. Okay, so here it must be, but there is no carbon-carbon triple bond stretching because the symmetric stretching of this alkyne system, which is already symmetrically substituted, this reduces the molar absorptivity coefficient, or let's say it reduces the intensity because it has very low dipole moment, and that is why it reduces absorption. Okay, so what we can say is That is why we are having no CC triple bond stretch over here for this symmetrically substituted alkyne. However, let us also look for the CH stretch. Let us also look for the CH stretch, but guys, there will be no CH stretch because this is not a terminal alkyne. So in this type of a system, the major peaks which were there to identify the system are not over here. Even the CH stretch is not there, and the carbon-carbon triple bond stretch is also not there. So it's very difficult in this in this compound to determine whether it is 4-octane or not. Okay, so this is the IR spectrum. Definitely we are going to have this sp3 carbon hydrogen stretching. We are also going to have the CH2 bending around 1475 centimeter inverse and CH3 bending around 1350 centimeter inverse. Definitely we are going to have that. We are also going to have the long chain a bit weaker over here, but still we can have the long chain peak for this, right? But the ultimate the 2 points which we are having, carbon-carbon stretching frequency and carbon-hydrogen stretching frequency, that we are not getting over here. Okay, all right. So now we are going to focus on the IR spectrum of the aromatic compounds. Alright, and quickly we are going to see what are the basic peaks that we can get. So in the aromatic compounds, basically, definitely we are having a system like this. If we consider benzene, okay, simple benzene, then the first thing is carbon hydrogen stretch. So this is our sp2 hybridized carbon. Alright, and definitely guys, we know that our value for the sp3 carbon hydrogen stretching was something 2900 centimeter inverse, or which means it is right hand side to the 3000, right hand side to 3000. So it must be left hand side of 3000 centimeter inverse, which means it is greater than 3000. Okay, all right, because it is between 3050 to 1310 1310 centimeter inverse. All right. So now what about the fingerprint region? The carbon hydrogen out of plane bending vibrations occur between 900 to 690 centimeter inverse. So this is there in the fingerprint region. And we had also talked about the alkene system, which was very similar to this, right? We had talked about the alkene system and it was very similar to this, both the stretching and the bending vibrations. Then the aromatic carbon-carbon stretching is between 1500 to 1600 centimeter inverse. So guys, if you remember that for the isolated alkene we were talking about 1660 1600 centimeter inverse. This was the range for the isolated carbon-carbon double bond. But here in aromatic stretch, definitely there is huge conjugation. So the conjugation has decreased the stretching value from 1500 to 1600 only. Alright, so definitely the value is decreased. Also we talked about this, that when we are having conjugation we might observe more than 2 peaks, right? We might observe more than 2 peaks. So 2 or 3 peaks often appearing in pairs at 1660 and 1475 centimeter inverse. So in the original spectrum, if we look at these carbon-carbon stretching, we are going to get definitely 2 to 3 peaks, okay, in the same area. Now the overtone or combination bands, they also appear between 2000 to 1667 centimeter inverse. All right, so the overtone or the combination bands, they also appear in this area. And now guys, there is a very important thing that we have to remember, basically, if we want to identify a spectrum, that is our ring substitution pattern. So for ortho, meta and para, we are having 3 different ring substitution pattern, and we are also going to see them. Okay, so it is also very easily predicted by the overtone or combination bands which are appearing in this area, in this region. Okay, alright guys, so let us now start with solving some spectrum problems. Okay, so if we are given the IR spectrum of toluene, so this is our toluene molecule, what do we expect? We expect CH3 stretch, we expect CH3 bending. Okay, so CH3 stretching is sp3 CH stretch. It is going to be less than 3000. Yes, it is going to be less than 3000. sp2ch stretch, that is definitely going to be greater than 3000. So it is on the left hand side of 3000 definitely. Alright. So now what we have is, the other thing is CH3 bending. Do we see a CH3 bending at around 1375? Yeah, a small peak we see. This is our CH3 bending. Okay. And we have discussed this in the last video also. Then we are having carbon-carbon double bond. This is our carbon-carbon double bond, right? And this is the stretching peak. The carbon-carbon double bond stretch is going to appear from 1500 to 1600 for the aromatic system. Alright, how many peaks do we have? This is our 1500 over here, because this is 1400, 1600, so this must be 1500. So at around 1500 we are having two peaks like this. 15 to 1600 we are having two peaks. One is a stronger one is a medium peak. Okay. Alright. So now these are the main things that we have to consider in the IR spectrum. All the stretching frequencies we have taken into consideration. Also looking at the bending vibrations, guys, what I have told was, see, in this region from 1600 to 2000, in this region, if you look at these peaks, so they are going to give you a substitution pattern. This over here is, these are the overtones or the combination bands. So they are going to give you the substitution pattern. So if it is like this, if it is three peaks like this, okay, three major peaks like this or with the equal intensity, then we can say it is mono substituted ring. So the ring is only mono substituted. Alright, and you would also get a mono substituted out of plane bending vibration, out of plane bending of the hydrogen carbon bond over here. Alright, so this is again, the range is again similar to alkene, around 720 centimeter inverse, but when you are getting two peaks over here, then you must understand it is our aromatic system. Okay, and definitely if you see this pattern over here, again three peaks of same intensity mono substituted. Okay. Alright, so now we are going to see some substitution ranges basically. So there are two major criteria for determining the ortho-meta-para substitution, which are, first of all, out of plane bending in the fingerprint region, which I have told you was approximately around 720 in the case of alkenes. But what about aromatic compounds? Let's see. So if we are getting two peaks, if you are getting two peaks in the same region, then it is mono substituted. And in the last example we actually had two peaks, so it was mono substituted toluene. Yes. If we are having only one peak, then it is going to be ortho substitution, right? And this is the bending vibration that we are talking about. This is the fingerprint region that we are talking about. Only one peak, then it is ortho. Okay, and then if we are having 1, 2 and 3, if we are having three peaks, then it is meta. Okay, and if we are having only one peak, which is definitely at a greater value, 1810 to 1850, then it is going to be para substitution. Okay, so this was about the fingerprint region, not the overtones. Overtones we are going to discuss, only the fingerprint region, right? So let me just get back to this area. So this is our fingerprint region. Here we are having two peaks. Here we had two peaks, and that is why we can say it is mono substitution. If we have three peak, then it would be meta. If we have one peak in this region around 750, then it is going to be ortho. If it is going to be greater than 800, 820, then it is going to be para substitution. Okay. So these were the bending vibrations, and I hope that you are able to understand. I hope that you are able to grab some knowledge from here. Okay. Now, yes, now comes the overtone area. The overtone area from 1667 to 2000 basically. So in this overtone area, we are going to see some substitution patterns. For mono we saw most of the 3 or 4 there were peaks, and they were of almost equal intensity, not a very huge difference. Okay. So these two things are going to confirm the presence of mono substitution pattern, right? The first thing is bending vibration, two bending vibrations, and also the overtone peak. Okay, what if we are having ortho substitution? Let's say we are having ortho substitution like this. So then for the ortho substitution, we have only one peak in the bending vibration fingerprint region, and in the overtone region we are having peak like this. Okay, so we are having two peaks like this. Okay, in the meta substitution, this is the type of the peak. It is basically, in the meta substitution, it is going to be like this. Okay, so basically only two of them are equal in intensity, the third one is small. So basically we are having three peaks over here. In the para substitution, we are having two peaks, and one of the peak is greater and the other one is smaller. So this is for the para substitution. Alright, so guys, even if you remember ortho, meta and para, that would be great, and that would be enough for once to determine that how is the structure going to be. And definitely there are a lot of other peaks for tri substituted at the 1 to 3 position, tri substituted at 1 3 5 position, 1 to 4, tetra substituted at these positions. So guys, you don't have to remember all of them, you just have to remember, if possible, mono, ortho, para and meta. Alright, so this is what you have to remember. That will be enough. Alright. Okay, so now we are going to see some spectra. So first of all, we see mono substituted, and guys, we just saw about the toluene. We just saw that we need two mono substituted out of plane bending in the fingerprint region, two bending vibration, overtones with this pattern. Okay, so we have already discussed this. So now we are going to move forward to another example. Yes, so here comes our di-ortho substituted benzene. Okay, so over here in the di-ortho substituted benzene, what should we observe? We should observe only one peak out of plane substitution at around 750 nanometer. Okay, centimeter inverse. This is going to be around 750. Okay, and in the overtone region, the pattern has to be like this. Okay, so if this pattern is followed, and if you are having only one bending vibration, then it is ortho. Guys, in the para also we had one only, but it was greater than 800. In the para substitution, it would be greater than 800, around 850. Also in the overtone region, the para is having only two peaks with 1:2 intensity like this. Okay, so definitely we can identify between ortho and para, and the rest of the molecule is going to be the same. The sp2 carbon hydrogen stretch, the carbon-carbon bonding bending vibration, also the aromatic carbon-carbon stretching, and so on. So now we are going to move forward with another example. So here I have taken meta diethyl benzene. So in the meta we had three peaks, isn't it? We had three peaks. So let's look for the three peaks. Yes, this is 1, 2 and 3. So we are having three peaks in the fingerprint region. Yes. And also looking at the overtone pattern, we can see that there are three peaks over here in this region from 1660 to 2000. This is also the definitely if you are getting this pattern over here, and also if you are getting three peaks in the bending vibrations in the fingerprint region basically, then we can definitely say it is meta substitution. Okay, so alright guys, so now we are quickly going to see the para substitution as well. So for the same compound, if we have taken the para substituted compound, then what is the difference that is going to be? So guys, now we observe one single peak only, but the single peak is around 800, or let's say it is greater than 800. If this is 800, it is around 850. So in the ortho substitution, the peak was less than 800, it was around 750 in the ortho substitution. Here it is 850 centimeter inverse. Alright, so we are getting one peak and we are getting these two peaks, this pattern over here. Okay, in the overtone region, definitely it is our para substitution, and rest of the compound remains the same because this bending and stretching vibration, everything is same. So that is why we have talked about the ortho, meta and para substitution in the case of aromatic system. I hope that you will be able to identify them by now. Okay guys, thank you so much for watching the video, and if you liked it, then please give it a big thumbs up. Also share it with your friends and also subscribe. Along with that, also press the bell icon for regular notifications. And guys, there is much more such free concept on the Unacademy website. Alright, so if you want, you can follow me over there and you can definitely watch my content, the special classes, the free video courses, and if you like, then you can subscribe for the plus subscription, which is a 6-month. Definitely for the 6 month there will be a lot of for the June 2020 preparation, and if you want, then you can take the 1 year or 2 year subscription package as well, as long as you want to study. Alright guys, thank you so much. I'll see you in the next video.